Hi, my name is Elaine Piller, and today I'm going to be presenting my elementary statistics final project. The purpose of my survey project is to discover how different people value fashion by observing their individual spending habits and overall consuming habits regarding clothing. So, for my survey questions, I have a total of 5 questions we asked regarding the shopping habits of Ventura College students. We have 2 quantitative questions, 2 qualitative questions, and 1 binary question. Quantitative questions are questions that have answers that can be counted or measured with numbers. They are also known as numerical data. So, my first question is, on a monthly basis, how much money in dollars do you spend on clothes? My second question, which is also a quantitative question, is, on a monthly basis, how often do you shop for clothes? We thought these two would be a really good question to ask because one, they're both quantitative questions, and two, these could possibly have a correlation with each other that we can use to interpret the data with. For my 2 qualitative questions, these are questions that cannot be measured or answers that cannot be measured or counted using numbers. So, in simpler terms, these are non-numerical questions. And qualitative is also known as categorical data. So, for my third overall question, which is a qualitative question, I have, in your wardrobe, what color of clothing do you own the most of? We decided that this would be a good question to ask because we thought asking Ventura College students what colors they own most of could signify a correlation between their spending habits, how much they're spending, and how much clothes they're getting because there are only a certain set of clothes in certain colors that are being sold in stores. So we thought it'd be interesting to question this. For our second qualitative question and fourth overall question, we have, out of the following options, which one is your favorite store to shop at? JCPenney, Target, Shein, H&M, or thrift stores? We decided to give our survey takers prepared options already to choose from so we could eliminate many different outliers in our data. We know that people shop at a huge array of different stores and places that it would be hard for us to account for them all. So we decided that it would be simpler to have 5 options and to have the people choose from that. So we are able to cipher through the data and make some use of it and make some connections with it. And for our fifth and final question, which is a binary question, these are questions that result in 2 answers, such as yes or no, true or false, or this or that questions. And for our question, we decided to ask, do you prefer shopping online or in stores? And before I go any further, I wanted to explain that we went wrong with this question, thinking that we were clear with our instructions. But instead of hoping to get 2 responses, online or in store, we ended up actually getting 4 different results rather than our intended 2. We ended up getting online, in real life, both, and neither. So unfortunately, we did have to scrap this question from our data project, but yes. And here are the raw survey results. So we have a total of 33 responses for our survey, which is a quite small sample size, but it is still something to work with. But we did have some problems because there are some difficulties that we had to deal with. We'll start with the easy ones first. So, simple cleanups we did was merely changing the letters to all be the same. So, I changed all the uppercase letters in the categorical questions into lowercase letters because in StatCrunch, it categorizes it into two different sections when in reality, they're the same thing. And some difficult cleanups we had to deal with was that there was one person who responded with periods for majority of their responses. So unfortunately, we had to switch these responses in the numerical questions to zeros. And then for the online or in real life question, we decided to put neither, even though that doesn't make sense that you prefer neither shopping online or in real life. But we couldn't exactly choose an opinion for them, so we just decided to say neither. We also had worded responses in our numerical questions. So as you can see in row 33 for the monthly spending column, someone put not sure. We merely put that one to zero. And in the next column over for how many shopping trips do you take monthly? Someone put rarely, which we put as one. And someone put three times, but that was an easy fix. We just switched it to three. And another problem we had was that some people put multiple answers for their survey responses. So as you can see in the same area that I was talking about, the column for monthly trips, in row 22, someone put 0 to 1, and we just decided to put this response as 1. And for the common colors, there is someone who put both black and pink. And since majority of the answers were black, I decided to go with the unpopular response and choose pink. And here is the beginning of the visuals for my survey questions. This is for the amount of money people spend on clothes monthly. So here we have two visuals, a scatter plot and a histogram. And as you can see on the histogram specifically, this distribution is left skewed. It is not a normal distribution, but I guess if you squint really hard, you can imagine it's a normal distribution if you try it. Um, and as you can see, there is a high concentration in the $40 to $60 area. You can see that in both the scatter plot and the histogram. To add, there are also gaps in the data. This is also due to the fact that there are big outliers in the data, which are the numbers $500 and $900. You can see that here and here in the scatter plot. These are also known as influential points in the data set, but I will elaborate on that later on in the correlation and regression area. For our second question, how often people buy clothes on a monthly basis, I decided to represent this question with a box plot because they clearly define the characteristics stated in the data. So here we can find the minimum at 0, the maximum at 5, and the median of the data set is clearly defined with the pink line at 2. And the interquartile range ranges from 1 to 3, which is really easy because it just means that the first quarter is at 3. First quarter is at 1 and third quarter is at 3, which works out really nicely. And then here you can see that there are also outliers here clearly defined with these dots. They are 8 and 15. And I know that pie charts are not the best visual to use when representing data, but I thought a pie chart would be a great option to represent the most common color in people's wardrobe question because it is aesthetically pleasing and this question is simple enough and it involves colors. So we need the colorful and aesthetically pleasing visual for this. And as you can see, black takes up a big chunk of this pie chart. It is the most common color people own in their wardrobes, with 22 out of 33 people choosing that. So about 2/3 of our responses were black. Coming in second is white, with 5 out of 33 people choosing that. And third is blue, with 3 people out of 33 choosing that as their most common color in their wardrobe. And for people's favorite stores, I decided to display this with a frequency table, ranging from highest frequency to smallest frequency. As you can see, there are 5 options given to us, and the results are that thrift stores was the most popular with a frequency of 12 out of 33 people and a relative frequency of 0.364. And next is H&M with 9 out of 33, coming in at a relative frequency of 0.273. And coming in close is Target out of 8 out of 33 at 0.242. And then tied for fourth, 2 people each voted for Shein and JCPenney's, so both of their relative frequencies are 0.061. And I like frequency table because they are useful. As you can see here, there are multiple outputs, but they're clearly organized in this table-like setting. And the relative frequencies show the exact differences between the frequencies that may seem close. So as you can see, H&M and Target, they are only one off from each other. But when you look at their relative frequencies, you can see just how different or similar they are from each other. So it's easy to differentiate the results between these frequencies because of that. And for my binary question, do you prefer online or in-person shopping? I thought it would be useful to also represent this with a frequency table to show how we got 4 responses instead of our intended 2. So at our highest frequency, we have in-store being the top option at a relative frequency of 0.485. Then coming in next is people choosing both, actually, which we did not expect at all in our survey. But it comes in at the second highest result, with 10 out of 33 people choosing this option and a relative frequency of 0.03. Wait, 0.303. I'm sorry. And next is online with a frequency of 6 out of 33 people. And the neither, that was the option that someone put as a period for some reason. But we still decided to include it in our data set, even though that may not be a valid response. Therefore, maybe invalidating having 33 responses out of all of our survey questions. But we decided to include it anyways at 0.03 at a relative frequency. Here, for estimating a parameter, I chose the question, what is your favorite store? And I decided to do a confidence interval to interpret how many people on the Ventura College campus choose thrift stores as their favorite place to shop at. My results for my 90% confidence interval, which is found at the bottom here, my results were 0.1995. Oh, no, sorry. My results were 0.2258 and 0.5014. And into percentage terms, this can be seen as 22.58% to 50.14%. And doing a 95% confidence interval as well, my limits were 0.1995 and 0.5277. And to translate this into percentages, it is 19.95% to 52.77%. And because wider confidence intervals establish a wider range of responses, there's a higher probability that the wider confidence interval, such as 95%, would contain our true population parameter. So to further this, There is a 32.75 difference in the 95% confidence interval range compared to the 27.5 percentage difference in the 90% confidence interval or confidence level range. This wider interval means there's a higher probability that the 95% confidence interval contains the true population parameter. Therefore, we are 95% confident that the proportion of Ventura College students who choose thrift stores as their favorite place to shop at falls between 0.1995 and 0.5277. And for my hypothesis test, I decided to use the question, how much money do we spend on clothes monthly? And between categorizing this as either a proportion or mean, this would be a mean because this is a numerical question, which involves numbers. And for my hypotheses, my null hypothesis for the test is that on average, students at Ventura College spend $100 on clothes on a monthly basis. And as you can see here, this is what it looks like in symbolic terms. So H0 equals mu equals 100. And for my alternative hypothesis, I hypothesized that the population mean is greater than 100, meaning that students spend more than $100 on clothes on a monthly basis. And this is what it looks like in symbolic form. And as you can see from the results here, we have a sample mean of 155, degrees of freedom at 32, and most importantly, we have a p-value of 0.0448. The results of my hypothesis test gave me this number, 0.0448, which is close to the significance level of 0.05. And because this value is just under the significance level of 0.05, this means that we should reject the null hypothesis that Ventura College students spend $100 on clothes on a monthly basis. Furthermore, these statistics show that students spend more on average than $100 on clothes on a monthly basis, which means that we would accept the alternative hypothesis. So for my correlation segment of the project, I decided to use the two questions, how much people spend on clothes monthly and how often they shop monthly. On the x-axis, I have how much money people spend on clothes monthly, and on the y-axis, I have how often people buy clothes monthly. And with this scatter plot visualization, the line of fit, as you can see here, actually touches some data points here, which means that the estimations were good and it falls with the data results. The data points in the survey fall in line with the estimated values, sorry. And for my R value, we have a value of 0.773. And since R values fall between the numbers of -1 and +1, and my R value is closer to 1 than 0 or -1, this means that there is a strong positive correlation between how often people buy clothes monthly and how much money they spend on clothes monthly. This strong positive correlation may not always automatically mean that the frequency of people buying clothes causes the amount of money being spent on clothes, as there have been plenty of graphs that have also resulted in strong positive correlations, but are not actually explanations of causality. In this case, though, it could be plausible to suggest that this is a matter of causality, since one variable can be dependent on the other. As you can see, the independent variable here is the money on clothes, and the dependent variable is how often people buy clothes. Another important thing to mention is the one big outlier for this data, which was someone spending $900 a month on clothes and shopping 15 times out of the month. If it weren't for this data point and probably the $500 data point here, um, I feel like the line of best fit would not be as steep. It'd probably fit more along the points over here. But alas, this does alter the line of best fit, which makes them influential points in the data set. For my conclusion, some key takeaways to remember is that we found out that some students do spend a lot of money and a lot of time on clothes and fashion, as you can see from the previous example. We also discovered that black is the most common color of clothing that people at Ventura College own. And we also found out that many students like to thrift. I'm wondering if that's due to maybe trends and also maybe spending habits, since I did take a survey on Ventura College students, to be exact. Furthermore, there is a strong positive correlation between students spending money on clothes and how often they shop. And another important thing to remember is the sample size for my survey was only 33, and 33 is also a stretch at the same time because I know that some people did not give truthful or accurate or even realistic answers for the results. Um, and it's also important to remember that if another random 33 were sampled on campus, there would not be the same results. Perhaps maybe if there were even an equal amount of boys and girls, the results would definitely not be identical to these findings. For what I would do differently, I mentioned it in the beginning, but I would want to fix the binary question, which shopping method do you prefer, online or in person, to in a way where people can distinctly choose between online or in person. So I would say online or in person, one of the two. My second thing I would fix would to be to alter the store options for the favorite store question. Um, I think the JCPenney option was not our best idea since JCPenney is kind of irrelevant now. They're going out of business too, so it's just not up to date with the current trends and trends in fashion now. And my third thing that I would change, it's kind of impossible, but in an ideal world, I would be able to share the survey in a way where people would actually take their time to respond and give out truly truthful answers. Um, I know that this one is a very specific circumstance because the responses in this were not the only questions that they had to respond to. I know that our survey had over 100 questions for us to respond to, so I understand why people did not want to take the time to respond to my survey questions truthfully. So ideally, I wouldn't ask as many questions as we had to for our class survey questions. And hopefully that would make a big difference in the results of our data. Because I'm assuming that maybe someone put an extra zero for the 900, maybe they meant 90 and spending 500. That could also have been a typo, but we'll never know since that was simply what we got and we had nothing else to work with. And overall, thank you for listening to my presentation and thank you for teaching us elementary statistics. I have learned so many new things and important things regarding statistics and how it applies to the real world. And I will definitely take this with me to my future endeavors and my professions.